Welcome back to my channel Kishore Sir Ki Pathshala. We are doing chapter Work and Energy 9 Cbse Science. Let's see today's part. Today we are going to see what we understand by potential energy. So let's take a rubber band which is easily available. A very easy activity to do. Now what we need to do, hold it at one end. Okay, hold the rubber band at one end and pull from the other. Okay, pull from the other end. Release the band at one of the ends. Let's see what happens. The band will tend to regain its original length. Obviously, the band had acquired energy in its stretched position. Right? What happens? The band acquires energy in its stretched position. Now, how did it acquire energy when it was stretched? Let us see the reason why it acquired it. Now, when you stretch the rubber band, okay, the rubber band was there. When you stretch the rubber band, what happens? You store energy in the band as what? As potential energy. Okay, so the energy is stored as potential energy. This is because the band is an elastic system. The property of elasticity is there with the band. So the energy is specifically called as elastic potential energy in this case. When you release the band, what happens? The potential energy is quickly converted into the kinetic energy. So the conversion of potential energy into kinetic energy is there, which causes the band to regain its original length. Potential energy is the energy of an object because of its position relative to the other object. Okay, see here. Here we have stretched it. What has happened? Due to the elastic system, it has regained potential energy. When you release it, what happens? The potential energy gets converted into kinetic energy. So you have come across a helical spring toy which is called a slinky, right? A very nice toy. You might have played it. So if you see this, a slinky acquires energy when it is stretched and when it is compressed, right? This is the stretching position and this is the compressed position, right? Okay, this is the stretched position and this is a compressed position. Now what happens when you stretch it? When a slinky is stretched, the force applied to it does the work on the slinky, right? Which transfer the energy to it and in the form of what? Potential energy. When compressed, what will happen? When a slinky is compressed, work is done against the spring. Work is done against the spring, which is stored as a potential energy. When the slinky is released, the potential energy is converted into kinetic energy or the energy of the motion. So we have seen how the slinky acquires energy in stretched and in compressed position. Now let's see another example of a toy car. Okay, if we take a toy car and if we take a toy car and if we do the windings of the spring coil which is inside, what will happen? The car will move. Okay, when a car is wound, the spring stores potential energy. The potential energy is stored in the spring, okay, or in the coil, right? We are putting a key like this and we are giving it. Okay, when the car is released, the spring unwinds and the potential energy gets converted into kinetic energy. It gets converted into kinetic energy. This kinetic energy gives the gears attached to the spring the velocity what it requires to move ahead, and this makes a movement in the car. How it acquires the energy? It acquires the energy when the key is used to wind it. How the number of windings affects the energy? How it affects the amount of energy acquired by a car depends on the number of windings. Okay, how many times you move this coil, right? Okay, the windings, number of coils, the more the windings, then what will happen, more will be the velocity, and the distance covered by the car will be more. Okay, so different is the number of windings, the different will be the number of distance traveled by the car. Now let's see, when an object is lifted against the gravity, what will happen when it is lifted against the gravity. So work is done on that object, and the object stores that energy as a potential energy. The energy is stored in the object's position, right? So what we have done here, suppose the object is at A position and we have lifted it at B position. Okay, now this is the distance, vertical distance what the object has covered. Okay, so the potential energy is what stored by the object at B will be the most. The energy transferred to an object is stored as potential energy if it is not used to cause a change in the velocity or the speed of the object. You transferred energy when you stretch a rubber band that we have seen. The energy transferred to the band is nothing but it's a potential energy due to the elastic nature of the rubber band. Work is done while winding a key of a toy car. The energy transferred is to the spring inside, okay, which stored it as a potential energy. The potential energy possessed by the object is the energy present in its virtue of its position. Then let's take another example of a bow and a arrow. Okay, now if you see here, right, we have got what we need to do. We need to place an arrow made up of a light stick, okay, on what, with one end of a supported by the stretch string on the prepared bow. Okay, so that we need to do. Now what we need to do, now stretch the string. Okay, suppose you have got a bow and this is the string, right? So you need to stretch the string, okay, and you need to put the arrow like this. Now stretch the string and release the arrow. The arrow is flying off the bow. Okay, what we see is flying off the bow. Notice the change in the shape of the bow. What we see that it regains its original shape. What happens is that the potential energy stored in the bow due to the change of shape is thus used in the form of kinetic energy. Okay, in throwing the arrow it moves forward. Okay, more the potential energy, more it will be converted into kinetic energy. Okay, now let's see the potential energy of an object at a height. Right, let us see at height what happens. Right, so what we see here is that an object increases its energy when raised through a height. Okay, suppose if you have got an object of mass m, right, object is there, mass m is there. Okay, now we have taken this object from ground to a certain height, right? Now what will happen, the energy it is gained. Okay, so this is because work is done on it against the gravity while it is being raised. Okay, we all know that there is a gravitational pull. Okay, now you are lifting something, means what is happening, against the gravity work is being done. The energy present in an object is the gravitational potential energy. This energy is nothing but it is the gravitational potential energy, right? The gravitational potential energy of an object at a point above the ground is defined as the work done in raising it from the ground at that point against the gravity. Against the gravity, you are raising this object, right? Now consider an object of mass m, right? We have got object, the let us consider object of mass m. Yes, here it is, object of mass m we have, right? Then what I need to do, if I take the object of mass m, let us see, we have got object that is of mass m, right? Now what I need to do, it is raised to a height h, okay, from the ground. This is the ground, the object is raised to a height h, right? The weight of the object is there, okay. The minimal force required to raise the object is equal to the, now let's consider an object of mass m, right? Okay, let's consider object of mass m. Let it, okay, let it be raised through a height of h. Okay, let us consider object of mass m, and let us see height of h, we have raised it, right? The minimum force required to raise the object is equal to the weight of the object. That is the force which is required. Okay, so we know that force is nothing but m into acceleration, but here it is g, okay, acceleration due to gravity. The object gains energy equal to the work done on it. Okay, let the work done. So we know work done is what? Force into displacement. Okay, so force into displacement is the work done. So we know that force we have put at mg into h. So work done is nothing but is my mg h. Okay, since the work done on the object is equal to mgh and energy equals to mgh unit is gained by the object, this is my potential energy. Okay, so this is my potential energy for the object, right? Now the work done by the gravity depends on the difference in what? Difference in the initial and the final position, okay, of the object, right? So initial and final position of the object, it depends, right? Vertical height, vertical state, vertical height, and not on the path, okay, and not on the path along with the object has moved. It doesn't depend on the path which has moved, it depends on the vertical height, right? So this is because gravity is a conservative force. What is the meaning? Meaning that the work by the gravity on an object is independent of object's path. It's independence of object's path, right? So students, I'm sure you have understood today's concept of potential energy. Okay, also we have understood the object which is taken up above the ground, okay, how the gravity, how the force has been applied against the gravity. Kindly like, share and subscribe my channel Kishore Sir Ki Pathshala.